This is video 2 in the series of Packer in the Cloud, and in this video we're going to deploy custom Linux and Windows images in Azure using HashiCorp's Packer tool. Just like the other cloud providers, we're going to provision 2 images, one for Linux and one for Windows. For the Linux image, the process is very straightforward across all the cloud providers. The system Packer uses SSH to provision into the machine. It creates a temporary user ID and password. And we're going to run a series of bash scripts where we're going to use the apt package manager to install Apache. And then we're also going to set up a collection of lightweight HTML games that run on that web server. This gives us an image of a game server that we can deploy and then connect to and test. On the Windows side, we're going to take Windows Server 2022, and in the Packer code, we are going to first apply all system updates. So at the time of the build, we'll have all the updates that Windows has available. Then we're going to install Chrome and Firefox. So this will give us a desktop environment that has 3 icons on the desktop. The first one is Edge, which is included with Windows builds. And then we're going to have Chrome and Firefox with the PowerShell scripts that we run. So provisioning in Windows is actually, for Azure, is actually a little bit simpler with Packer, with AWS or GCP. Packer handles all the WinRM configuration for you. All you have to really do is set the user ID and password, and it's almost as easy as SSH. Now, this makes sense because WinRM is a Windows Microsoft protocol. So, and Azure, of course, is an Azure. Azure is a Microsoft offering as well. And so this makes sense that they made it so easy. Now, after we provision all the PowerShell scripts that does the installs, we are going to run Sysprep. Now, unlike AWS, there is no special tool you call Sysprep directly. And it's absolutely necessary to generalize the Windows image so you can use it in Azure. Now, as a part of the provisioning process on both environments, we create a Packer account. And that Packer account, you can SSH to on Linux, and you can RDP on Windows. Now, we generate a random password, and then we've created a key vault and created a secret Packer credentials in that key vault. When we go to test these, we're going to actually go into the key vault and grab the Packer credentials and plug it into the Bastion host that we use to connect. Now, once the image builds are complete, and the image builds take quite a bit of time, anywhere from 30 to 45 minutes, we're going to turn around and deploy both images or VMs based on those images and test. So as a bonus, we have deployed in this project a Bastion host, which allows you to connect without a public IP address in the Azure console. Now, we do have a public IP address, so it's kind of redundant, but I just make it a habit to use Bastion for debugging. It just makes it really easy to get into the servers and see what's going on. So we will use Bastion during the demo to test it out. So at the end of this project, you should have a complete end-to-end Azure solution for Linux and Windows that you can take and then adapt to your own projects. Okay, now let's go over the Packer workflow from code to creation of the image. So we are using Packer code. We're using HashiCorp control image, HCL. Online, you might see a lot of JSON code that has this, but that's the older style. You want to use HCL. And there's really 2 blocks to your HCL code. The first one specifies which image to use, whether it's Ubuntu or Windows. So it's very provider specific. And then the second part of the code is the provisioner code. And that is consistent between all the providers. So the first part, you specify what image, and it spins up an instance, and then it runs the provisioners. So we kind of take this code, we're going to put it into the Packer CLI. It's going to run that first block and say, okay, give me an Ubuntu image. Give me a Windows server. So it's going to spin up a base image as a VM. And then it's going to either configure for Linux a temporary SSH user for provisioning, and that temporary SSH user has admin privileges, so you can sudo, so you can do installs, you can do apt install. And then if it's Windows, it's going to be WinRM, and it also creates an administrator account that you can run PowerShell code to run things. So once it initializes and has either the SSH or WinRM set, it's going to go to the provisioning stage. Now, the provisioning stage for PowerShell is really, for the most part, a set of bash scripts that get run. You can also upload small content into that. I would not recommend doing big installers in there, and we'll cover that in the Azure specific tips and tricks. But it's going to run a lot of bash code. So in that way, it kind of feels like Docker at times, but we're actually creating a VM instead of a Docker image. And then we have the WinRM, and it's going to run a series of PowerShell scripts to install. Now, the thing to keep in mind is Linux is really designed for batch interactions if you're using apt or yum, whatever your package manager is. It's the exception that installers prompt. On Windows, it's a little bit different. If you're running PowerShell and whatever you're running ends up posting a dialog, it's going to go to that machine's console and it's never going to reply. So what you'll end up doing is the provisioner will just hang and eventually time out. So there are tools like Chocolatey that kind of fill this gap of having silent installs with PowerShell, or you can do it manually. So we've done it manually here, and we have to be very careful with the options that we put into the provisioners to make sure that it runs. The other thing that's you can also run into is if you do not put in the dash wait for it to complete, what will happen is it'll do the installer and the install will run silently, but if the provisioners exit before they finish, you can get things into a bad state. So after all the provisioners run, the bash code for Linux, the PowerShell, if they all do successfully, it goes to the creates image. If there's any failure, any return code that's non-zero, it's going to kick it out at this stage and fail. So once they've run, it's going to create an image, and the image is created. Once it's done with that, we destroy the VM, and then we're left with the process. Now, one thing you will notice if you watch this build is what Packer actually does in Azure is it creates a temporary resource group for provisioning all the resources. So you can actually watch this build and see how it works. The other thing too is you can just use the default network. You don't have to pass in your own network. It seems to work pretty well there. So now let's talk about the prerequisites for the build. Now we do have a video out there, Azure and Terraform Easy Setup. And if you've never done one of these, this might be a good starting point because it's very simple. It walks you through the steps in the Azure console that you need to do to actually run these. And so here are the things you need. You need an Azure account. And within that Azure account, you're going to have a build identity with all the options that you need for that. And again, this video covers it. Then we have the AZ CLI. We need to install that. A lot of the scripts that build from one phase to the other are using that. And then you need the latest version of Terraform, and you need the latest version of Packer. Okay, so in the build, the first step is we're going to download the code repository and then run the apply script. Now, this build is designed for a Linux environment. So let's go, and I'm going to copy that, and I'm going to go to my Ubuntu development environment and paste that in. Okay, so the first thing I'm going to do is we provide a check env script, which allows you to run. And what it's going to do is make sure that your project is set up, that you have the client secret subscription tenant ID all set, logs into Azure, and says, okay, you're ready to go. I'm going to do apply sh. So it started, and while it's building, this is going to take 40 to 45 minutes. But what I'm going to do is, before we wait for the build, let's talk about the build overview, the build process. So there's really three phases to the build. The first phase is we're going to configure the network and create the project resource group. It's a pretty lightweight part. And the second part, we're going to use Packer to build the games image and the desktop image using the network infrastructure for phase one. This part of the build that takes the longest, I'd say at least 20 minutes. It's really 20 minutes times 2 because we're doing this twice. So expect at least 40 minutes on that build. Then finally, the third phase, we're going to, after everything's built successfully, instantiate a VM instance using the desktop image and one with the games image. Okay, the build has completed. So we're going to do first is let's go back to the documentation and take a look at the architecture diagram of what got built. So we're building in US Central Region, and we created a virtual network, and we have two subnets. Now, remember with Azure, subnets are not by availability zone, by their function. So that's within our virtual network. And then outside our virtual network, we're going to have in our resource group the games image, and then the desktop image, and then finally the key vault. And in the key vault, that's where you're going to have the credentials that we're going to use to access the system. So let's first look at the game server. So I'm going to go back to our build environment, and I am going to go to the games DNS name, and I want to copy that. And let's go here, do new tab, and V. And there we have the games. My favorite is Frogger. There's a GitHub link about where I got these games from if you're interested. I appreciate it being out there. It gives me something to play with these demos. So that's it for the game server. So now let's bring up the Azure console and let's go into the resource group. And the resource group is Packer RG. And click on that, and you'll see everything that we just talked about in our resource group. You've got the Bastion information, you've got the desktop instance, and you've got the games instance, and you got the images that Packer built. So let's first go into the key vault. And in that key vault, there is the secret for the Packer account. Show secret value, copy this into face buffer. Then I'm going to go back here and I'm going to go look at the games VM. So I'm going to go to the games VM and I'm going to say connect via Bastion. And the user ID is Packer. And the password is the thing coming from secrets. Look about right. And I'm going to hit connect. We've opened the SSH session, so I'm running this Packer account as sudo ability, so I can do sudo bash, and I'm going to there, and I can do systemctl status Apache, and it'll show Apache running, and then if I do cd var lib, and I guess it's just var www, and that's where the HTML games from the Packer build got copied in. So now let's go look at the Windows desktop. So I'm going to close this and let's look at the desktop image. So I'm going to click on the desktop VM and I'm going to go connect via Bastion, and I'm going to use the same credentials again, Packer, and do paste. That looks right. And this is going to start an RDP session into the desktop instance. And of course, this is Windows Server 2022. Edge is included by default. We've installed via Packer, Chrome, and Firefox. And the last thing to check is check for updates. And you can see that it is up to date as of the build. So those are the two instances. You can take this project and adapt to your own. And what you want to do is be good stewards of your cloud account. If you're done with this project, is we have a destroy script. And so let's do the destroy. Okay, now let's go over the Azure specific issues with Packer. The first one is good news. WinRM configuration is the easiest across all three providers. It's almost as easy as SSH. You need to specify a couple of attributes to configure a WinRM, or a couple of different attributes for the configuration, and then Packer does the configuration for you. I suspect it has its own VM extension that it runs, but it's all hidden and abstracted from the Packer user. Second issue is Sysprep. Is you call that directly. You must call that for prepping a Windows image. And there's no tool like EC2 launch. So you create Sysprep and the options are included in the project. I have to figure out every time, which is why I have this project out there so I can look at it. Then I've had pretty good luck with using the default networking with Packer. I could just say, okay, I want to do a Windows 2022 image, I want to do an Ubuntu image, and it'll wire all the networking for you. Other platforms, I had to create some network issues to get it to work, and I suspect I probably I'd probably hit some other advanced issues where I'd have to do it in Azure, but it seemed to work out of the box pretty well for me, much better than the other two. The next issue is not really specific to Azure, but is specific to Packer, and that has to do with Packer allows you to load content from your local, build environment into the VM. It's very, very slow. So if it's a bunch of text files, you're cool. Shell scripts, you're cool. When you start getting installers, it might be, several megabytes, 100 megabytes. It becomes really unwieldy, almost impossible to use. And so what you want to do is actually download in your PowerShell scripts or your Bash scripts, download the content and apply it that way. Don't try to upload it locally from Packer into the VM. Now, one common pattern there is, you can get it off the web, but if you need to have your own set of installers, what you can do is create a storage account, put your installers in the storage account, then all these default images have the AZ CLI, so you can use that AZ CLI, or if you do a SHA, right, with the Azure storage account, you can download the install. So use an Azure storage account to stage your installers and then download them during the Packer build. Now, the last one is sort of not really Packer related, but it's just a reminder that custom data for Windows instance, if you put PowerShell, it doesn't actually run. It just copies it to a directory called C:\Azure data and then custom data like bin. And what I did on this project, which I thought was a little nifty, was I defined a VM extension that would take that custom PowerShell that was there, convert it to a PowerShell file, then run it. So effectively, with this combination of a VM extension and custom data, it'll behave like the other cloud providers. So that's just a pet peeve of mine, the way the custom data doesn't work the same with Azure, but I understand why they get it. So that's it for the Azure-specific Packer issues.